Hi everyone, I'm Tom Farrand. I'm the Head of Solutions Engineering here at Seldon. I'm going to be talking to you today a little bit about how the future of financial services will look with the adoption of machine learning and the operations that are associated with that technology, and how that can help to enable competitive advantage over a range of different companies and clients within that setting. And so what I wanted to first start is setting the scene. And so today, traditional financial services is really being invaded. Challenger banks, insurtechs, fintechs are challenging incumbents' ability to retain and grow their businesses. And this is forcing changes in their target operating models as they shift to more of a platform operating model, and forcing the incumbents to react to these changes in the market. If they cannot react quickly enough, there'll be parallels to the Spanish occupation of the Central Americas. There'll be less slavery and genocide, but certainly a massive transfer of wealth within the industry as these newer startup, more agile and reactive companies come and take customers and client market share from those incumbents. Fortunately, incumbents are not helpless within this scenario, and competitive moats such as the ability to handle compliance and regulatory requirements are huge advantages over these newer startups. Furthermore, this isn't a strictly competitive landscape. So I've chosen quite a provocative example, but the partnerships are equally as important within this world and are just as required in order to thrive and ensure that both sides of this coin, be that the startups and the fintechs, as well as the incumbents, actually succeed and thrive in today's climate. And so this kind of movement of wealth in the 16th century, caused by the invasion of the Americas, actually triggered the 16th century price revolution. So this caused inflation, continent-wide inflation within Europe, as huge amounts of precious metal were actually shipped back across. This was at the rate of 1 to 1.5% per year, which for the time, while we're facing 9% inflation rises today, at the time, and given the monetary policy then, that was actually a huge increase. And it's possible we're seeing a similar inflation in fintech valuations, thanks to kind of what is at stake within the industry. Now, the point that I would like to make here is that the Spanish were able to ship across so much precious metal using crude methods because it was so abundant and returns were so high. It was really easy to get the metal back across into the European continent. But times have since changed, and modern precious metal mining is actually focused so much on microscopic amounts of gold, and advanced techniques are required to yield quantities of the precious metal. The machine learning revolution is similar to this. In the beginning, crude techniques gave huge returns, but as the space becomes more and more competitive, more sophisticated techniques are required to keep pace. However, this does not mean there are diminishing returns. As we can see in the parallels drawing back to the precious metal mining, in the 16th century, the Spanish Empire managed to ship back 1.5 tons worth of gold for the entirety of the century. But in 2021, the worldwide amount of gold that was actually mined and purified rose up to 3,000 tons. And so, this means that there aren't diminishing returns for those who succeed, both in the mining world, but also more importantly, in the machine learning space as well. And so let's next consider some of the use cases for machine learning, which the financial services industry are looking to generate superior returns and user experience. We've got here we stumble upon one of the immediate challenging aspects within the industry, which is variety. So, we've got algorithmic trading, fraud detection, hyper-personalization, eKYC. The algorithmic trading makes use of time series data. That hyper-personalization could be both tabular or as well as text. eKYC could even leverage imagery. And so all of these different data types need to be considered and actually pose challenges. And the reason that customers are demanding these changes is because of the technology landscape. Their expectations are getting higher. A 2017 study found that every 100 milliseconds of additional page load time, which Amazon pages actually had, lost them 1% in net sales. So there's a bar and significant costs associated with raising that bar, but those costs are outweighed by the costs and the loss of revenues that will be incurred if you do not keep pace and actually enable this hyper personalization and this superior user experience across these use cases. The nature of the industry is that it's being disrupted, and the industry doesn't have the skills to keep up with all of this variety of use cases. And we'll touch on some of the areas how MLOps can help with the testing and validation of models across these different life cycles. Now, you may be asking yourself, what is MLOps and where does it fit? Really, the key focus here is that machine learning operations is about building the factory, not the model. It's about taking machine learning models from a lab-based environment or a POC and actually operationalizing them and industrializing them at scale. So building out compliance and governance processes and actually having it evolve from the lab. Now, MLOps is made up of more than just a technology. Technology only enables change, and we'll talk about some of the technologies that Seldon provide to enable that change a little bit later on, but it doesn't deliver it. This ultimately comes down to people, process, and technology working harmoniously together. And so MLOps is all around those three core tenets, but really focused on how do you build the factory to enable you to continuously produce high throughput, high quality models without having any downtime, without having reliability issues, to ensure that you can keep serving your customers in the way that you care about. And so if we think about the kind of machine learning landscape, all of the use cases that are built into a financial services organization are linked, and actually they rely on one another. And so this is really where that kind of factory scale becomes important, because if you can't handle this variety of use cases, it's very difficult to move up this impact scale and generate further and further value. So if we take a look at financial forecasting, that clearly relies on capital allocations. And so a machine learning model that can be built in order to perform financial forecasting may rely on another to perform capital allocations, which is then in turn related to risk-adjusted pricing. Risk-adjusted pricing would be very, very difficult to perform without accurate fraud models. EKYC would be impossible to actually perform correctly, or can be enhanced further by the biometrics. And so this slide isn't focused on the kind of complexity of these use cases. All of these are equally complex and have a huge amount of mathematics and complex financial domain knowledge to actually achieve them correctly. So don't confuse this with simplicity. But the point here is that they're all linked with one another. And without taking this broader picture of machine learning as an organizational challenge, and one that needs to have infrastructure associated with actually building the models themselves and kind of industrializing those at scale, these wouldn't be enabled. These use cases wouldn't be enabled at an industry and at an organizational-wide setting. So this can be seen as a sort of ladder of maturity. Each use case is enabling the next. And so if we think back to MLOps being the kind of enabler for the industrialization of machine learning, and then we looked at some of the kind of use cases that were associated with an FSI organization, I highlighted that variety is one of these key challenges. And so as we can see here on the left-hand side of the slide, what data scientists and model builders really want is choice. They want to be able to select from a range of different tools and actually build out algorithms and build cutting edge and state-of-the-art models based on these tools. However, what the organization really wants is control and governance, and actually a single pane of glass with which to monitor and observe the changes and impacts that these machine learning models have. So this control could be at an infrastructure level, so it could be where those models are running. It can be at a governance and compliance level, who approves what and how do those get into production. And it also can be at a kind of machine learning framework level, which is what we've got on the slide here, whereby you may want to use TensorFlow for your image-based algorithms. You might want to use SageMaker. You may use H2O for some time series forecasting. And so what this kind of choice and control paradigm allows you to have is whereby you enable choice across each of those different areas, but you have the control through a single centralized platform such as Seldon, it means that you can enable agility. So data scientists can actually adopt the latest tooling, knowing that they can still get that into a production environment, allowing you to move faster, enable competitive advantage, and keep that edge over others within the space. So we always use Capital One as a reference, and they've actually built a machine learning as a service model around this concept. They have Seldon, which is that centralized function, a centralized platform for model deployment, monitoring, management, and explainability. And then they actually centralize functions across the business on this platform, allowing them to break down silos. And if we think back to that use case slide that I showed just now, it enables them to build hierarchically on top of the existing use cases to enable others and allow for that hyper-personalization, that competitive edge in the space that they're in. If we now take any given use case, so this could be your chatbot, this could be your capital allocations model, it could be your time series predictor, this is the maturity within a given use case. And so what Seldon looks to say is the maturity increases as you move from left to right of this slide. Many organizations have infrastructure and processes governing the data readiness, the feature engineering, the actual generation of these machine learning models. What Seldon then allows you to do is manage those at scale, but ultimately to serve and orchestrate them so that they can move from that lab setting into generating business value and ROI for your organization. So orchestrating those models and actually setting them up within the environments you care about. Monitoring them. So machine learning models change over time. The data that they infer and predict against changes over time. So alerting when you have anomalies, not just in a fraud detection case, but any sort of business any sort of use case setting, it's really critical to pick up on those outliers. Picking up data drifts. So how those models, how that data is changing over time and whether that's causing your model's performance to degrade. Are you getting lower accuracy because your data's changed? And then finally, actually adding the explainability, the ability to understand why a model made a given decision is clearly critical in such a regulated and compliance-heavy environment as financial services. What we'll consider next then is machine learning at scale and how we see this at Seldon. And so this is an architecture slide. It wouldn't be a technical presentation without an architecture slide. And really what we're going to touch on are the areas where we believe that you can enable this machine learning, this operationalization of machine learning, and therefore enable that high velocity creation of use cases and thus driving of competitive advantage using tools such as Seldon. But we won't solely focus on that. So just to talk through this, in box one, you can see the experimentation. So tools such as Jupyter Notebooks allow you to actually create and train your models. You then may have automated pipelines for existing use cases to actually generate new artifacts and rebuild models based on new versions. And then finally, really where Seldon takes over is allowing you to serve that onto a platform that you care about in a scalable and on-demand way and provide you with the ability to actually set those endpoints up as well as the monitoring capabilities surrounding that. So we'll go through some of the key additions, the key considerations that you should make when you're looking at enabling machine learning at scale in this MLOps setting. So the first is really agnosticism. So this comes back to that choice and control piece. You want the choice of model building and pipelining tools as this prevents process and skill set change. Also, it allows you to adopt new tools into the future, enabling you to continue that competitive advantage. So really, Seldon is just a plug and play piece within this, and we are agnostic to those other toolings. The next is kind of the ability to have on-demand infrastructure. If you're looking to scale to hundreds, thousands, tens of thousands of machine learning models, you need to be able to actually serve those whenever you would like. You can't have this lag time of setting up, Spark-based or Hadoop-based infrastructure in order to actually have your machine learning models being serviced. And really, the on-demand infrastructure allows this self-service pattern to be kind of developed. So data scientists or model builders can actually go into the platform, service and bring up their own models without the interference of other teams, meaning that you can actually move more quickly, and bottlenecks around DevOps teams or more constrained resource don't actually occur, and you can maintain pace with how many models are being created across the enterprise. The next is the ability to have a governed, a single view of a machine learning model across its life cycle. And so this not only allows you to actually understand where this model's come from and how it's been created and having that lineage aspect, but it also provides a shared understanding across teams of what this machine learning model is attempting to do, how it's going to be doing that, and what sort of data it should be fed. And then finally, it improves your time to value by allowing you to actually audit and govern these models correctly. But also when new versions are created, you can immediately place them into an A/B test, a canary or shadow deployment, and actually view the metadata against them to understand how this has been created. Next, we think about the deployment auditability. So clearly understanding how models got into the production and where they came from. So when changes to that deployment were made, what those changes were. So did we change the version? Did we go from version 1 to version 2? And then finally, who initiated them? But also this auditability allows us to roll back to previous states, meaning that breaking changes aren't as impactful. And if we do roll out models that do negatively impact our user experience, those negative impacts are controlled and contained. And so just as a recap and a summary of what we've been talking about, I think the industry has come around to the fact that machine learning can offer a road to El Dorado. It can offer huge returns on the investment that it's made. Technologies within this space can enable this change, but they can't actually deliver it. It comes down to those core tenets of people, process, and technology. And in order to actually maintain competitive advantage within the machine learning space, you need to consider that machine learning operations is all about building your factory. And in order to do that, you need to think about the diversity of data that you have, the ability for users to come in and self-service their deployments, and agnosticism to the tooling that they want to use, and actually future-proofing your architecture through those three sort of considerations. Seldon can help across those different aspects, so please do feel free to reach out and get in touch, and we can certainly discuss that in further detail. So that's all from me. Thank you very much for your attention.